Now, from physiology to culture, we've established the key to human evolution is adaptation. We're naturally creatures of change, and it seems even our milk use has impacted human evolution through the years. AUT Institute for Applied Ecology Director Steve Pointing joins me live in studio for our science chat this morning. Good morning, Professor. Thank you for joining us. So, how has the way we consume and use milk, how has that impacted on evolution?
Well, yeah, it's very interesting, Rachel. There's a new study just released this week in the journal Nature, which is the foremost journal for science, that really is a synthesis of many recent studies. And what it shows is that probably one of the biggest single selective events in recent human evolution has been the ability to digest milk as adults. Because as you know, as infants, we all digest milk, all mammals in fact. But as adults, generally, there's huge variability. So if we look around society today, some people are able to tolerate lactose, the milk carbohydrate, others are not. And it causes quite severe symptoms when you consume it.
So we've adapted, some of us have adapted the ability to consume lactose as an adult, when in the past that wouldn't have been the case. It's simply something you have as an infant.
Well, that's right. And what this study is showing, it really is the explanation for that. And the explanation actually goes way back to the Ice Age. So our ancestors during the last Ice Age essentially found milk as toxic as adults. But two very fortunate things happened in our evolution quite recently. About 11,000 years ago, our early ancestors in the Fertile Crescent, which is what is now the Middle East, developed ways to process milk, to remove part of the lactose by essentially creating yogurt and cheese and other products. So that allowed them to digest milk. The second thing was that a spontaneous mutation arose in the human genome that allowed adults to switch on the gene that allowed them to digest lactose, which otherwise and previously had been turned off.
So, to put this in perspective, if dairy, didn't exist in essence, how different would our path through evolution have been, do you think?
That's interesting. What this study suggests is that these two events, which essentially led to the prevalence of agrarian societies in human evolution, allowed us to basically even out times of famine. So, where we'd be growing crops or hunting and gathering, the ability to process and preserve milk products essentially led us to be more able to withstand hard times. And it's been estimated using genetic modelling that probably it increased our fitness as a species, that is our ability to pass on our genes to offspring, by about 20%, which is really quite a significant amount for a single mutation.
So of course dairy is not the only thing that's impacted on our evolution. I want to talk to you a little bit about climate change and the role that's played as well.
Yeah, this is an interesting different take on climate change. So it's long been proposed, since the 20s in fact, a scientist called Raymond Dart proposed what we call the savanna hypothesis. And that is the notion that changes in climate have led to our evolution from tree-dwelling species, essentially ape-like creatures, to walking upright and walking through grasslands. The rationale being that forests declined as the climate globally got cooler in the last 6 million years. And as grasslands increased, we had to walk around and keep our eyes above the grasses to look for saber-toothed tigers. The problem has been that the lines of evidence to support that have been very disparate. So we've essentially had global climate data from ocean cores, which are offshore, and almost all of our human evolution data has come from the Rift Valley in East Africa. So what this study has done, this recent study, has basically moved the mountain to Mohammed and brought together the cores and the fossils by basically driving a truck up the Rift Valley with a drilling rig on board and digging down and identifying local evidence for climate change. Now, what's interesting about this is it does appear as though it's not climate change per se which is driving major speciation events in human history. It's actually fluctuations in climate, so major swings between especially wet and dry periods, which have resulted in our speciation.
It's fascinating. Steve Pointing, appreciate your time this morning. Thank you so much.